Good morning, students, and a snowstorm still continues out there. We're going to start our February 2nd lesson with a do now prompt about supporting our dreams, and we'll talk about that a little bit in class. Our objective will be to continue with our learning with real numbers and our essential questions. Let's remind ourselves, what is an irrational number? What are those rational numbers? And how can we further classify rational numbers? Our assignment today will be to answer the do now in our team's Q3 folder and notebook. We'll watch today's video, and we only have one page today to work. Then we will answer our exit ticket again in class notebook. Most important, show your work to the teacher. Even if it is not done, you get credit for that. So for our exit ticket, we're just going to answer the question, what is the difference between rational numbers and irrational numbers? For homework, if you haven't finished the lesson, you can complete it for homework. To get full participation credit, let's have our cameras on. Respond when your name is called at the beginning, middle, and end of the period. Show your work on camera to me. If your camera is not working, then you can send a photo, and here's my email address to send it to. Let's remember tomorrow, Wednesday, is a full day of distance learning classes, and MAP testing begins on Thursday and Friday. So please look for new calendar invites because the schedule will change on Thursday and Friday. Here's our do now. We have a quote. The quote is by Mae Jemison, and the quote is, "Never be limited by other people's limited imaginations." So you might have an idea of something you want to accomplish in yourself, but maybe somebody else does not think it's possible. Maybe they have a limited imagination. So the question is, how will you convince people close to you to support your unlimited dreams? Will you convince them through showing that you're serious by reading a lot about what you're interested in, or by working very hard toward what you're interested in? Will you convince them by constantly asking about this particular topic, whatever you're interested in? Whatever it is that you have a dream toward, you can convince others to get on board with your dream by keeping it at the forefront of everything you do. So I'd like you to answer that question right here. We'll get back to our exit ticket in a second. Remember, all your work must be shown to me. So let's get started with our lesson. We're working on the real number system. So we're going to name all sets to which each value belongs. Remember, we can remind ourselves we have generally the highest level of rational and irrational numbers, which are our non-terminating, non-repeating numbers. Rational numbers are numbers like fractions, but also rational numbers can be integers, those positive and negative numbers. The whole numbers, which are natural numbers, all positive numbers, but the whole numbers include zero. The natural numbers do not. So name all sets to which each value belongs. We can simplify the negative square root of 64 to negative 8. And when we simplify that, let me just, we see that that will be, it's an integer. It's rational. And it's also part of the real number system. Negative 5.3125 terminates, it ends, so it's not only real, but it is a rational number. If it did not terminate, it would be irrational. Pi does not terminate, so even though it is a real number, it is an irrational number. The absolute value of negative 29 equals 29, and that is a natural number. It is also a whole number. It is an integer. It is a real number, and it is a rational number. 9 minus 3 to the second power. 3 to the second power is 9. So this is 9 minus 9, which is 0. 0 is a whole number, but it's not a natural number. It is an integer. It is a rational number, and it is part of the real number system. Now, 4 to the negative 2 power equals 1 over 4 to the second power, which equals 1/16. And that is a rational number, not a natural, not a whole, not an integer. It's a rational number. And it is part of the real number system. And in the next section, we're asked to place a letter in the smallest set that contains that value. So A is a terminating decimal, so that's rational. It would be irrational if it didn't terminate. B, we can actually reduce 30 divided by 3 is 10, so B is a natural number. C is the square root of 144, which equals 12, so that's also a natural number. And D is a fraction, negative fraction, 1 2/7. That's a rational number, not an integer, not a whole number, not a natural number. Now, E is going to be the only whole number here because 0 is the only number that is part of the whole number system, but not part of the natural number system. F, we do have a terminating decimal. It ends. So if it terminates or repeats, it's a rational number. G, negative absolute value of negative 13 equals negative 13, and that is an integer. H is irrational, okay? The square root of 95 will just go on and on and on, and the negative square root of 95, it will just go on and on and on, like pi goes on and on and on. I, the square root of 324, is a natural number. J, a fraction, negative 17 over fourths, is a rational number. And K, 9, the square root of 9/16 would be the square root of 3 would be square root of 9 over the square root of 16, which would be the square root of 9 is 3, the square root of 16 is 4. And that is a rational number, so that's K. And L, the cube root of negative 125, well, that would be negative 5 times negative 5 times negative 5. Okay, so would equal negative 125. So that means that the cube root of negative 125 equals negative 5, and negative 5 is an integer. So let's clean that up a little because we want to write that all of these are real numbers. So let's circle all the values below that are rational numbers. Let's see, 18 is rational. Negative square root of 75 is irrational, so we can't circle it. 6 1/14 is rational. All fractions are rational, 15/3. Now, the square root of 6 will just go on and on and on. It is irrational. The cube root of 84 is rational because that would be 4 times 4 times 4. And negative 0.4, where the 4 repeats, is also rational because it repeats. We have the repeating symbol. So let's answer some questions. We're going to use always, sometimes, or never. Natural numbers are they always, sometimes, or never integers? Always. Irrational numbers are always, sometimes, or never rational numbers. Well, no, they're never. That's the whole definition, the definitional difference. Irrational numbers do not end or terminate. Rational numbers do. Number 11, rational numbers are always, sometimes, or never real numbers. That's always. And square roots are always, sometimes, or never rational numbers. Well, sometimes. It's a little tricky. Sometimes the square root can be rational, like L, but sometimes the square root can be irrational, like H. So that's our real number practice for today. Let's go to our exit ticket and answer the question, what is the difference between rational numbers and irrational numbers? Rational numbers terminate, that means end, or have a repeating decimal. And irrational numbers never terminate. So thank you so much for your hard work, for committing to your schoolwork on these snowy days, and thank you for working hard. So keep on practicing because as you do, you'll be great.